Good morning, guys. So today we're going to talk about NoSQL. As you can see, I also have a comic on the slide, but I realized it's really small when I print it out. Hope you can read it though. So before we get started, I just want to quickly tell you homework due on Friday, homework 3. And how's everyone doing? I see a lot of guilty faces. All right, good luck. I think the TA sent out this email last night, and it's good. A lot of you already filled it out. So as you all know, next week will be your project demonstration number 1. So you're going to schedule time with the TA to do demonstration for her. And she sent out this doodle sheet last night, so if you haven't done so, you can go out to fill it out. Okay. I think she sent it in this email, so you just have to click the link. All right. So that's for that. And okay, let's get into today's lecture. So we are at lecture 23, and today we're talking about NoSQL. So I think a really cool thing is, in our department, NoSQL has never been taught before. So this is the very first lecture of NoSQL, okay, in computer science, in Penn State, I mean. So because it's not included in the textbook, but I guess quite a few of you might have already heard about NoSQL and wondering what it is. It's actually a trend right now. And we're going to talk about why there exists NoSQL and what's the difference between NoSQL and SQL that we learned, and why we should use it, why people are using it right now. All right? So here is kind of like an imaginary evolution of NoSQL. Okay? Oh, by the way, so all of these things, material-wise, we don't really have a textbook that you can study from, but I put some references at the very back of the slide, so you can just go on those web pages. Okay, so those I think are really good materials you can learn from. So this is the imaginary evolution of NoSQL, we can say. So at the beginning, it all started out by just having things stored as key value. Okay, everything has a key, has a value. But at the time, people found out when we do just key value, it's hard to get a range of keys. Then people say, okay, let's make it a tiny bit more complicated. Let's do order key value. And when we do order key value, it's powerful because doing key value actually is a lot efficient in storage-wise. However, even though now it achieves doing a range key value, range of keys, it's hard to do any computation on the attributes, okay, the fields that we have. And that's why then people get into big table, which is what we will talk about later, is the column family. And then further, people developed document database and then graph database, actually for the purpose of social networks. Okay, so all of them, even though people are starting out with the intention of keeping things simple, it's still gradually getting a bit more complicated. So they are all kind of moved towards SQL, but they are still not SQL. So what exactly is NoSQL? Now we show you how things are actually happening. So NoSQL actually stands for not only SQL. Okay, so it's not like we are not using SQL. It's not only SQL. So NoSQL, it is a non-relational database management system. It is designed for distributed data stores, actually. So far the SQL we have learned, it actually doesn't work so well when you have distributed computing going on. So NoSQL actually helps a lot in terms of distributing systems. In data stores nowadays, you can imagine in Google, Facebook, Twitter, Instagram, large amount of data, terabytes of data, or petabytes are being generated every day, every second. Okay? So SQL, initially, when it was first proposed, relational data model was proposed in the 70s, they weren't thinking about this humongous amount of data. So that's why NoSQL are actually emerging now to help out what SQL cannot handle. And also the data storing nowadays may not require the fixed schema like we learned so far. In SQL, we always design the table has these attributes. But if you go on Facebook nowadays, you can see they have tiny bit of function changes every day. And you can imagine if we do that in tables, then you have to keep updating the fields every single day because we have new attributes we want to introduce, right? So NoSQL helps that as well. So who uses NoSQL? These are just the more famous companies right there. Google for sure, LinkedIn, Facebook. Not sure whether you guys know this, Foursquare. That's Foursquare, and Twitter, and Adobe. And so this is from a list of companies using NoSQL. I haven't really gone into each single of them to see what they're using. But I looked into Twitter. So Twitter actually used a mixture of a lot of different kind of databases. Some part of them, they still use SQL. Okay, but just for different kind of purpose, because Twitter is so big, for different kind of purpose, they use different databases. Even when using NoSQL, Twitter uses quite a few different kinds of NoSQL databases. Okay, I think that just depends on, under Twitter, they have little different groups working on different stuff, and they adopt different kind of NoSQL database. So this is one of the tweets I found a while ago, and yeah, I really like it, so I actually retweeted it. So that's people's understanding for the notation. That's what we talk about, what we think of what is NoSQL throughout the history. And in the 70s, we have no SQL. SQL was not even introduced. Okay. Then gradually SQL was introduced because the relational model was introduced in the 70s. Okay, the SQL was based on that. And then in the 80s, people know about SQL. Right, that's when people start using SQL. In 2000, because of the internet, people are like, no, we don't like SQL. People start to realize, and you guys are learning it now, but anyway, people in the 2000s start to realize, okay, maybe SQL is not the best. So around 2005, people say maybe not only SQL. So that's the NoSQL we're learning today. Okay? And then back again, 2013, now we still go back to SQL. But I think it still changes here and there. So right now, people are debating, they still think MySQL is better, or they think NoSQL is better. So it really depends. I think people have different kind of opinion based on what application they want. I'm missing anything right here. All right. So why NoSQL? If so far, as far as we know, we think SQL is pretty powerful, then why do we want NoSQL? So the one of the major difference between NoSQL and SQL is that when modeling the data, NoSQL and SQL, which is a relational model, actually thinks very differently. So the starting point for relational modeling, they will think, what answers do I have? If you could recall, whenever we are talking about modeling your database, so far we think about what data we store. And then we design the database based on that, right? We have sailors, we have the sailor's name, all these things. So the database is based on that for the design. On the other hand, NoSQL, it will be starting from what questions do I have? So what do I want to answer? So that's how they start by designing it, instead of what data do I have. Because NoSQL is so flexible, so later on when your application is running, you can still update it. Okay, so how you initially design it does not have to fully depend on what answer you already have. Instead, you can just think about what question do I want to answer later on. Okay, and also NoSQL data modeling often requires a deeper understanding of the data structure and algorithms than relational data modeling does. In this sense, it's because SQL actually takes care of a lot of retrieving the data and how the data is stored for you. But as you saw earlier at the very beginning of the imaginary evolution of NoSQL, NoSQL a lot of times are just simply based on key values. So you can design your own data structure on top of that. Okay, so you can have a deeper understanding of those, and you can also design how you want to retrieve the data differently. Okay, so the next point is gonna be kind of mind-boggling for you guys because we just learned about normalization and learned about different normal forms. And that's for SQL. So two of the major tasks whenever people start working on NoSQL, the first thing is to duplicate data. You'll be like, what? We spent so much time removing the duplication. But when you really learn about NoSQL, we go back and duplicate more data, which is kind of crazy. And the second thing is we would denormalize it. Okay? So we have learned so much about normalization, and in NoSQL, we denormalize it again. So I won't get into too much about these today, but then in the next few lectures, we will talk about more what we mean by data duplication and normalization, and why we do that when we work on NoSQL. Okay. So NoSQL solutions are surprisingly strong for hierarchical or graph-like data modeling processing. So when you see this line, it's interesting how at the very beginning of the semester we were talking about different kind of data models, and then we say now we decide relational data model is the most powerful. That's why we want to learn about it. But here when you go back, we say NoSQL are surprisingly strong for hierarchical and graph-like data. So you can see hierarchical and graph-like data is actually really similar to the data model we learned at the beginning. There are two more, right, other than relational data model. One is hierarchical data model, and one is a network, okay, network data model. So it's kind of interesting, people are going back and forth at different kind of time, people have different needs, right? So now people have found the graph-like model is important, okay, in a big application is because of the social network, how people are connected to each other. Okay, so this graph is just showing you at different kind of decades, we have different needs for different data. And at the very beginning, when it's in the 70s, all these things you can think of, maybe bank transaction or booking tickets, like for the train, for the flights, or just buying stuff like order transaction for the shops, businesses, stuff like that. So it's mostly related to the business transaction data. But then in the early 90s, when I was born, and then you guys were born, it's around the time and the internet starts to take off. Right? And then web applications data started. You can see it's growing exponentially. So these things include like personal user information. Like nowadays we shop online. We actually give them a lot of information about ourselves in the social graphs. That's the Facebook, Twitter, Instagram, all those things. And also geolocation data. Like you check in or when you didn't turn off the location sync, you walk around and that actually updates to the cloud. Right? And also user-generated content, so the blogs, tweets, all those things. And YouTube is a big one. And machine logging data. You go to a website, you click on everything. Actually, it's all logged, all recorded, like your click streams, right? So SQL database were never designed to handle these things. They would never imagine like data will be generated at this kind of fast pace. Okay? So that's why we need NoSQL. So let's take a look at the comparison between relational database system and NoSQL. So I'm sure you guys will be really familiar with the left side. Okay, cross out the very last one. I decided not to talk about it. So for relational database management system, we say RDBMS. The data is very structured and organized, as we have already learned, like the sailors table, the reserves table, the boats table, they're all very structured and organized. They can put into tables, okay? And to deal with relational database, we use SQL, right? So SQL stands for Structured Query Language, and we also know data and its relationships are stored in separate tables. That's what we have learned, and that's what you're working on for your project right now. And also we have DML and DDL, which is the data manipulation language and data definition language. DML is for like updating the table, inserting tuple into the table, deleting tuple from the table, and data definition is creating the table, if you remember. Okay. And also, remember when we learned about RD relational database, we learned about ACID properties. Okay, so the C stands for consistency. So, relational database has really tight consistency. However, on the other hand, NoSQL, it has no declarative query language. Okay, so that's all we were learning. I'll tell now, like chapter 5, we were learning about how we can implement the query language. NoSQL has nothing like that. Okay, and NoSQL, pretty mind-blowing, no predefined schema. When you start, you don't have to define how the schema is going to be like at all. Just start it and then start. Okay, in NoSQL, they have different kind of categories taking care of the data, how they will store it. So we have key value pair, we have column store, we have document store, and graph database, which we will talk about each later. Okay. And here also, instead of focusing on AC property, NoSQL focus on eventual consistency. So what this means is that the system will become consistent over time, eventually. Okay, so what happens in between actually is not guaranteed. Sometimes in the middle of it might not become completely accurate, but it's so tiny, so it only guarantee you in the end it will be consistent. Okay, so rather than considering AC property like we did in relational database model, we care more about just eventually it's right. Okay, and the data is unstructured, weightless structure. And also compared to the AC property, NoSQL actually also has its own property, and it's the cap theorem, okay, which we will talk about later, which is a pretty interesting idea. And also compared to SQL, where SQL actually focuses a lot more on how you aggregate the data, how the user eventually will view the data, because it has a relational idea in there. NoSQL prioritizing high performance, high availability, and scalability, which is more of an application for nowadays. Okay, so that's for NoSQL, and doing a comparison between it and relational database model. So what exactly is cap theorem? Cap theorem, similar to AC theorem, each letter stands for one thing. Okay, so for C, it stands for consistency. And right here, the consistency we are saying is like data in the database remains consistent after the execution of an operation. So it's actually, you might think it's very similar to the consistency we talked about in the AC property. However, as I said before, NoSQL actually takes care of distributed system way better. So the consistency in cap theorem can also have an interpretation where we say all nodes see the same data at the same time. Okay, distributed system had different nodes in the system, so what they care about is the nodes are seeing the exact same thing. Instead of some people see this, we'll see the other thing. Okay, so that's the consistency. Slightly different from the AC's properties consistency, but the higher level idea is the same. Okay. And the A stands for availability. The availability, here I only say system is always on, no downtime. You'd be like, for sure, right? And it's actually also saying it guarantees that every response the user sends will receive a message of fail or succeed, okay? So in relational database, even though this can be guaranteed, it wasn't being emphasized, okay? So this is an emphasis in NoSQL. Finally, the P stands for partition tolerance. So, as we said earlier, because this NoSQL is heavily on distributed systems, so partition tolerance means that the system continues to function even though the communication among the servers is unreliable. So you can also think of when it happens, some arbitrary partition, okay, system should keep going. So you can partition the system into different nodes, they should keep working, okay? So one interesting thing is that, remember in AC property we said relational data model that all the transactions, doesn't matter what, have to fulfill AC ID, right? However, in cap theorem, theoretically, it's impossible to fulfill 3 of them at the same time. So the system will only aim for achieving 2 out of 3, okay? So 2 out of 3 means like among the C and A and P, we will have different kind of combinations. So it just depends on what your application wants, what your system wants, and you pick 2 out of the 3. Okay. So let's take a look. We have different kind of combinations of C and P. So here you can see we have consistency, availability, and partition tolerance. And that's their combination right there. If you look at CA, when we only have consistency and availability, ignoring the fact of partition tolerance, we are basically saying we drop the emphasis on working well on the distributed system. And that gets back to our original relational database, okay? And here, when we have AP, which is availability and partition tolerance, these are the current databases that try to put emphasis on this. So these are just the names of those databases. Yeah.
Oh, I don't get why you can only have 2 of the 3.
What?
I don't get why you can only have 2 of the 3.
Oh, so I kind of glossed through that because it was proposed by a researcher, and then he proved all these theories in the paper, so then he said only 2 out of 3 can be achieved.
Okay.
Yeah.
I'll just take your word for it.
Yeah, so let's just take it for granted.
Okay.
2 out of 3 can be achieved. Yeah, that's a good question. All right, and then if we only care about consistency or partition tolerance and we sacrifice the availability, then that's CP. So these are pretty famous if you take a look at these databases. I'm not sure whether you guys have heard of it. Anyone heard of MongoDB? Yes. Okay, so that will be the one we will learn in the next few lectures. Okay, so it's just different kind of databases have different focuses. So NoSQL, so far it sounds great, but it still has pros and cons. Okay. Yeah.
NoSQL for our project?
Huh?
Can we use NoSQL for our project?
You can, but then it's kind of like, because so far we've worked on it towards in a way that's relational model. But if you still want to do it in NoSQL, I'm totally cool with that. Yeah. All right, so the pros and cons. Pros is high scalability. That's the whole reason we're using, right? We were talking about the motivation of the web application and everything, and for distributed computing, lower cost in the sense that because things are mostly storing key values, so it saves a lot of space eventually, so it's lower cost. And another good thing is the schema flexibility. So we talked about at the beginning when you start database, you don't even care about what schema you're going to store. Okay? So also it can be semi-structured. Okay? And in NoSQL, we don't have any complicated relationships. Not like relational database. All we care about is how the entities are going to be connected together, what are the relationships between them. However, one of the biggest cons is that it has no standardization. There's no best answer in NoSQL. Everything is just based on what you think. Okay? Some people might think it's awesome, but a lot of times you don't know what you're working towards. You don't know what's the optimized for your system. Okay? And also because it's so new, right now it has very limited query capabilities. Okay? But it's just a temporary thing. It's just right now. It's not like SQL. It's so developed and it has already a lot of ready-made, prepared queries that you can use. So in this rest of the lecture, what I want to talk about today, I want to introduce you with 4 different types of NoSQL database. Okay. Today there's nothing really too technical, but it's just kind of like sharing some thoughts with you guys and some knowledge. The first one is key value. Okay, key value, which is the simplest one, as we saw earlier in the imaginary evolution. Key value database is the first one. And the second one is called column family. And the third one is graph database. And the fourth one we'll talk about is document database. So here I kind of change up the order actually evolution-wise. It's key value first and then column family, then document database, then graph. Okay. But I kind of just put it this way if that's the order I want to talk about. So one thing to note that is actually there's no single solution you can say it's better than the other. So in NoSQL it really heavily depends on what your application is. For example, when you have social networks to store, it's better to use the graph database, right? You don't want to go back to column family or key value. It just really depends on what you want to use. So I think it will be a good idea if you guys want to try out NoSQL in your project, if you haven't started the coding part and you want to try it out. Because I think if you have started it, then don't discard the part you have done. Okay, so later on I will also tell you a few existing database for these NoSQL categories that you can choose from. Okay, of course, I'm not going to have experience in all of them, but I have 2 out of all, so I can tell you what they're like. The first one, key value database. So it's the most basic types of among all the NoSQL databases. So that's how everything started. People are still saying, let's just store the data as key value. Okay. One of the main benefit of it is whenever you retrieve something, you only retrieve from the key. That's it. You only care about primary key. And there's nothing else you compare with. So it can get to be quite hassle because how you're going to structure it really matters. But every time when you retrieve something, it's from the primary key. Okay? And it is designed to handle huge amounts of data. And the person who proposed it is Amazon. They proposed it in an academic paper, and they call it a Dynamo. So now if you look at DynamoDB, that's the original key value database. Okay? So it allows the developer to store schema-less data. We just don't care about schema at all, which is really different from what we have learned so far. And also, the database, it actually stores the data as hash table. As you can imagine, we have key value pair. So by doing hash table, it's quicker to search through which key you actually want. Okay? So each key is unique, as we said. Every key is a primary key. And the value, here's the interesting part. The value, instead of following the rules like relational database, where we say the values can only be atomic. Remember, we can't have a set, we can't have a list of things in our SQL database for the values. NoSQL, it actually doesn't really care. You can either have the value being string, value being JSON. You guys familiar with this? JSON? I'll show you guys soon in MongoDB. Okay. Question?
What does it mean when schema-less? Like, does that mean that it doesn't really have, like, can you have rows that have fields totally different from another field?
Yeah, exactly. That's exactly how. So when you start it, you don't really design what the schema is going to be like. And each row insertion doesn't have to follow the other rows at all. Okay? So I'll show you guys how JSON is like in the next few lectures. And another interesting thing is you can also put in a blob. Do you guys know blob? When I first heard it, I just think the name is funny, but blob is basic large object. So what blob is, here I have a definition. So blob, basically, data stores, just store the data, okay, for blob, and without caring what's inside. So it is the application's responsibility to decode it, to understand it. So sometimes you can just put in like a huge whole string, and it's just HTML, but it won't care. It won't care what you're actually storing. Or you can store in, I don't know, it's actually music, and it doesn't care. Okay, audio file. But the application will take care of decoding it. So that's one of the cool things. Key value pair for the value, just store whatever you want. Okay. And for the key, it's really cool as well. The key can be strings, hashes, lists, sets, sorted sets. Okay, so key doesn't have to be just a string or just a value. Okay, or just like numbers. But still remember, key has to be unique. Okay, among all records. So for key value, they can be used as collection dictionaries and associative arrays. So they're actually really similar. Associative arrays really similar to the idea of map, dictionary. So it's easier to look things up. Whenever we talk about key values, looking things up. So key value stores follow 2 out of the 3 CAP. The first one is availability, and the second one is partition. So we only talk about, out of the 4 categories of NoSQL, we only talk about CAP in here because key value is the only one that it's kind of cleaner. All of the databases follows A and P. But the other ones, they have different kind of emphasis. So then I won't talk about the CAP. So key value is suitable for shopping cart contents. You can imagine user being the key, and then the rest is the value. Okay? What has in the shopping cart. Or individual values like color scheme. So you can just look up key value. It's really quick. These are just some of the application. Of course, it's way more than that. Yeah?
So the keys can be like anything, right? But wouldn't all the key types have to be the same, or else how would you do the lookups? Or can you have like one key be a hash and the other one be like a string?
I think it depends on the database, whether they have that restriction.
Okay.
Because as long as it's unique, then they can differentiate it. But maybe having different types will make it less efficient.
Sure, that's what I was thinking.
All right. So this is just a pictorial representation of how the key value would be like. It's nothing fancy. You just have the key and the value can be blah, anything. So key value is really simple. Some of the databases for key value. This is the beginning of everything. That's the Amazon DynamoDB. Okay, so they are the creator of key value database. I forgot when they proposed, like in the 80s or 90s, around those times. And then Redis. I actually really like it, so I used this one before. If you're thinking about trying it out in your project, you can try that one. It's really easy to get your hands on, and they have a really strong community support, so the documentation is pretty awesome. And if you try Redis tutorial, you can go online and you can they have like an interactive session you can learn with it. So it's pretty nice. And another one, the last one is Ryak. I'm not really familiar with this one though. Okay? So these are just some of the examples of key value database. I decided to put these slides because I just feel like now the logos for the database are so nice. So I have one slide each. They're just pretty. All right, so that's for key value database. Okay, so nothing fancy about it, but that's how it all started. Okay. The next one is column family database. At first, when I learned about it, I think it's kind of awkward in some sense, but I'll show you how it actually works later. So for column family database, the primary work on columns in every column is treated individually. So quite different from what we learned in relational database, but kind of it's based on key value. So the values of a single column are stored contiguously, and column stores data in column-specific files. Okay, so far it's still like what's going on? But okay, in column stores, query processes work on columns too. So basically, we're just saying we care about columns so much that we need the column families database. What it's actually taking care of is each row, they may have different combinations of the columns, different attributes. Some are missing, some are there, okay? For example, the first row we have column ABC. Second row we only have BC and then E, okay? So not everyone has the same column. But eventually when you want to compute the aggregation among the columns, so let's say we want to take care of the min, the sum of the column family optimize that. Okay, so they will retrieve the same column really quickly out of all of the rows. However, key value doesn't really optimize that. Okay, it doesn't even care what you're storing, whether they have the same columns. Okay. So here, all data within each column data file have the same type, which makes it ideal for compression. And yeah, that's just basically what I was saying. Column stores can improve the performance of queries as it can access specific column data. Okay, so high performance on aggregation queries. Okay, so if your application really cares about aggregation along the columns, then column family is pretty awesome. Yeah, and just like I said before, the various rows don't have to have the same columns. Okay, so this is kind of the core concept of NoSQL. You never put constraint on whether the rows should have the same attributes. Okay. So one pictorial representation of the column family you can see right here. These are each row. Okay. So sometimes they share the same column, and sometimes they don't. Okay. So that's basically it. I am not certain how commonly used column family database is, but Google has the big table, so I guess it's pretty well established. So Google Cloud Big Table, it is one of the column family database. Cassandra, I think it's by Apache. It's also one of the examples. And another one is called SimpleDB. And the third one that I want to talk about, which I personally really like, is the graph database. So I like graphs. I like social network analysis. That's my research, and I like it. So graph database, it stores the data in graph. So how many of you have taken algorithms before? Algorithms. So in algorithms, I guess you guys have all learned graphs, right? Nodes and edges. Okay. So graph database is capable of elegantly representing any kind of data in a highly accessible way, and it is a collection of nodes and edges. Okay, so that's how things are stored in the graph database. Here on your slide, I have a typo. I said each node, but it's actually each node. I typed it wrong. So in graph database, each node represents the similar idea we have in relational database. So each node represents an entity. Okay. So as you can imagine, maybe when we have graph database for Facebook, each entity can be a user on Facebook. Okay, and each edge then represents a connection of relationship between two nodes. For example, you can have an edge between two users if they are friends, edge between actually a user and a post if the user have liked the post before. Okay, so then if you have a graph that has nodes representing different types of things, it can be a fan page, it can be a post, it can be a message, maybe, like a chat conversation among a group, and having different kind of relationships between these nodes, then we say this kind of graph is heterogeneous. Okay. So in graph database, every node and edge is defined by a unique identifier, and each node knows its adjacent nodes. So what's so powerful about graph database is you only, for each node, you only just let it know what it is connected to. Okay, so it doesn't have to store that much. You just need to know what's next to it. And if you want more, then you propagate, hop to another node, and then you know more of the information. So as the number of nodes increases, the cost of a local step remains the same. So even if you have more nodes, yeah.
So like going back, you said like relationships are like edges between the nodes. So if you want to have a like ternary relationship or like relationship like aggregation of some sort, how do you represent that in this?
Oh, so the thing that is similar to relational database is actually each edge, they can also have their own information.
Okay.
So they have the attributes as well.
So there can be an edge starting from an edge and going to a node. If there has to be a ternary relationship.
I think that graph pictorially when you represent that, it won't look that way, but in your attributes of your edge, you can store that this also involves a third node. Okay? But I think when it all started out, they weren't thinking about ternary. Okay, it's just like basically between two. So that's most common in social node analysis as well. Okay. So as we said before, because each node only has to know the adjacent nodes, so even as the number of nodes increases, the cost of a local step remains the same. Okay, for example, Facebook doesn't get slower everything you do because more users are on there. Okay, it doesn't take longer to find your friend when you put on the search bar. If more people are registering every day, it's still the same. Okay, so this will be a pictorial representation of the graph database. It's kind of pale, but here you can see. Here we have Martin, right? Martin is friend with Pramod, and Martin is the author of the book, right? And this book is in the category of database. Okay, this kind of thing. So that can be a representation of graph database. And the funny thing is, it looks like the network database we have learned before, which was replaced by relational database. So things are going back again. Okay. So when we take a look at relational model versus graph model, how do we map the idea between them? So in relational model, we have tables. And in graph models, we have vertices and edges. Okay. Vertices are nodes. Okay. Nodes and edges. So that would be like the tables in relational model. And in relational model, we have rows Then the rows are the vertices. Again, the nodes. Okay. And for the columns in relational model, that is like the key value pairs. Okay, in graph. And when we do joins in relational model, that's actually taken care of by the edges in the graph model. It just like connect two nodes together. Okay, so that's for node graph model. So some of the examples for graph database. So I was searching for the logo the other day. I just laughed at that one. I think it looks hilarious. But for Neo4j, I think that's the most famous one among all of the graph database. And that's for graph database. Just consists of nodes and edges. All right, another benefit of the graph database is that when you think of the relationships in relational database, whenever you are going to create a new relationships between two entities, you actually have to start out creating a whole new table for that, right? A whole new table for the relationship, defining what kind of schema you will want in that table. But in graph database, you just add an edge, and that's it. Okay, just add a new edge. So it's really easy to establish newer kind of relationships. For example, I think Facebook, they introduced, was it in Spain, like last week or 2 weeks ago, that you can put different kind of emotions on the post, not just like. You can also have, I don't know, like happy or different kinds, but it's just in Spain. They started out there. So that means you have different kind of relationship with the post now. Okay, so that would be one of the examples. All right, the last one I want to talk about before we end this lecture is what we will actually learn in the next few. Yeah.
Can you like combine the uses of these different databases? I have like a relational and also a NoSQL.
Yeah. Actually,
isn't Facebook mainly MySQL?
I'm not sure about Facebook, but I know Twitter, they have a mixture of a lot of different databases. So they also use SQL, but at the same time, they use Redis for NoSQL. So I think under a whole system, as long as they can communicate, yeah, however you want to do the ports, then that will work. Okay, so it doesn't have to be just one. So maybe for you guys for the project, you can have a little part taken care of by NoSQL. Right? Okay. So for the last one I want to talk about is document database, which is what we will get our hands on. I'm not sure whether Friday, but next week for sure. Okay. So document database, it is a collection of documents. But the documents here are kind of different from what we know. It's not just like articles. Okay, documents can be anything as long as like text, and you can have a semi-structure. Doesn't matter. The data in this model is stored inside documents, and a document is a key value collection where the key allows access to its value. And documents are not typically forced to have a schema, and therefore are flexible and easy to change. So I think most of the document database, they rely on the format of JSON that I just briefly showed you before, and I'll show you next time how JSON looks like. Okay. So documents are stored into collections in order to group different kinds of data. Also, documents can contain many different key value pairs or key array pairs or even nested documents. Okay. So next time, yeah, I should have included, but next time when I show you a format of JSON, you can get a sense of and get a feel of how nested it will look like. So you can keep nesting in. So it's a key value pair. In the value, you have another key value pair. And then in the value, you have another key value pair. So you can have the value of the value of the value. Keep going up. Okay? So that would be a very powerful thing to look at in document database. So I'll just quickly talk about how it's like today. So when we map it to relational model, for the tables, we call it the collections. Okay? And for the rows, that would be documents. Okay? So one collection consists of multiple documents. And for each column, really similar to the graph, it will be the key value pair. And one thing to note that the function we could do, which is join in relational data model, is actually not available in document database. Okay? I'll show you next time how it's like and why it's not available. So here we have a quick example of how the document database will look like. Then I realize I have a little snippet of JSON. That's kind of how it's like. Okay, so you can see we will start out the key value pair. Outside we have, here is the customer ID. And then we describe what the customer is like. So here is like customer information. And then we have another one is the billing address. And you can see they don't care about whether the value has to be atomic. And also, if you want to make it nested, you can actually have company and then colon, and then have more attributes for the company. So you can just keep nesting it. Okay, so this will be really similar to what we will learn for MongoDB actually. So two of the examples of document databases, one is MongoDB, one is called CouchDB. Very relaxing, I guess. But for MongoDB, I don't know, I just think it's really funny. For MongoDB, that's what we will learn next time. I think I won't ask you guys to install MongoDB yet because I found there's an online terminal we can use. But I'm not sure whether it will become a disaster like last time when we were trying to do MySQL and everyone crashes. But I'll send you guys an email as soon as possible to let you guys know. Okay? Even though you don't have an install, I can still do a demonstration on Friday. And I think I'll include MongoDB in midterm 2. Okay? Along with the SQL that we learned. So if, no, that's fine. What was it? I think it's November 10th. It's coming soon, actually. Yeah, so here are the references if you want to take a look. I think they're very fun to read. Okay, they write it really nicely. And I will post homework 4 on Friday. That will be on NoSQL, on things we learned. Okay, and don't forget about homework 3 due on Friday. All right? So see you guys on Friday.